Hi Year 5, Miss Chloe here, taking over your science lesson today. Last week Miss Beverly went through evaporation and condensation with you. And in today's lesson, I'm going to go through the water cycle. We're going to learn and cover the following learning objectives. To know that water changes states but is never lost. Water vapor rises as a gas due to evaporation. Water vapor cools and turns back into liquid through condensation. So just to recap on those two very important words, condensation and evaporation. You've already learnt about these two terms already, but we're just going to have a quick recap just to keep it fresh in your minds. So condensation. As the water vapor, gas particles escape the heated liquid through evaporation, they mix with the air. When they come into contact with a cooler temperature, they condense. The particles slow down and come back together. They turn back into a liquid. So we can see here that there's a flame heating up the water inside of this kettle. The water molecules are heating up and they're getting quicker and quicker and quicker, and then they are escaping through the spout and up and out. They've turned into a gas called water vapor. They then start to rise because they've evaporated, and then when they reach this cold, cool ice lid, this lid with ice on it, it then slows the molecules down and they come back together and they turn back into a liquid. We call this condensation, and then you can collect that liquid in a beaker. So evaporation, as the liquid water is heated, the particles start to move faster and further apart, and water vapor gas particles are pushed out and escape as a gas form. They rise and start to mix with the air, so we just went through that process. So now we have a really good understanding of condensation and evaporation. So is water ever really lost? Can we lose water? No, we can't lose water. It just changes state from one to another and then back into another. It goes round and round in a cycle, and we call this cycle the water cycle. So we're going to watch a video now about an expert talking about the water cycle, so we get a better understanding of that movement of water, because water is never really lost.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old, the same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle, so simple even small children understand the basics, yet so complex the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With two words: flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. in the snowpacks atop mountains like the Sierra Nevada, in the Great Lakes, in rivers and streams, in reservoirs and watersheds, in wetlands, in the soil, in and on plants and trees rooted in the soil, and beneath the soil, in water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants, and trees.
Like you might imagine someone in the game of football intercepting the pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscape, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward so it will move
through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of a liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw up groundwater.
And plants pull that water up through their stems into the leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee-worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air. Mixed with smoke and dirt particles in the atmosphere, cooled, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier, until they are so heavy they fall again, as rain or snow, sleet or hail. Precipitation, collection, runoff, interception, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
Okay guys, so that was the water cycle. So just in summary, just to go through that a little bit simpler, We have the sun heating up the surface water, either in the sea or water here on land. And then we get evaporation, so that water starts to rise as a gas, so it's turned from liquid to gas form. It evaporates up and up. As it evaporates out, it starts to cool down and condense, and then we get the formation of clouds. Wind will carry those clouds, and they collide with each other, they mix with each other, they become bigger and heavier. So the clouds become darker. This is when we start to get precipitation. Precipitation can be snow, hail, it can be rain, it can be fog or mist. That then returns back down onto the surface of the earth. We then get things like collection from rivers and streams, and ground runoffs. This is where it collects on a mountain and then it runs down and runs off the mountain and back into places like the sea. Can also have underground water where it sinks down into the mud and the soil and takes millions and millions of years to then make its way back over to the sea. And that is the water cycle. So there are a few little experiments that you guys can do, and I'm going to stop the video now because I'm going to do a different video for the experiments.